Hello students, welcome to P.Tech. For this particular video, we will discuss about the topic the phase and group velocities. Okay, so coming to that, the phase velocity, it is given by the symbol Vp. And what is the definition there? The wave with a single frequency propagates with velocity is known as the phase velocity. So for phase velocity, we have a single frequency and that frequency propagates, that one is called the phase velocity. From the definition, we know the Vp means phase velocity is equal to lambda by t. Lambda means the wavelength and t is called the time. And for this, we can write it as Vp is equal to lambda into f. Why I am writing this? Because the frequency and the time, both they are reciprocals, right? One each other. That's why I call like this, where Vp is equal to lambda is equal to 2 pi by beta into f, or 2 pi f we call it as 2 pi f is the angular frequency omega by beta, where Vp is called, the expression it is Vp, the phase velocity is equal to omega by beta, which mean it is the ratio of angular frequency to that the phase shift constant. Okay, the angular frequency to the phase shift constant is called the phase velocity. Am I clear? Okay, so phase velocity is the expression is very important on online. So many times it was given on online. And what exactly the ratio means? Okay, angular frequency to this one. Case 1 I have. For the pre-space, let us consider I have that Vp value. Vp is equal to 1 by square root of mu naught epsilon naught. And can you tell me, anyone, what is the value of mu naught? Mu naught is called the permeability of the pre-space. Yes, that is called mu naught is equal to 4 pi into 10 power minus 7 Henry per meter, and epsilon naught is equal to 8.854 into 10 power minus 12 farad per meter. Can I substitute there? 1 by 4 pi into 10 power minus 7 into 8.854 into 10 power minus 12 under root. I got the value approximately, it is 2.99 into 10 power 8. So it is the value, it is approximately is equal to, it is 3 into 10 power 8 meter per second, right? Okay, so that is equal to the value 3 into 10 power 8 meter per second. Vp is equal to, for the free space, the velocity of propagation, it is 3 into 10 power 8 meter per second. Suppose if you consider the dielectric, it is not the free space, that way consider there is a dielectric. Okay, so where epsilon becomes epsilon naught epsilon r, then Vp is equal to, how can you write that? Mu naught into epsilon naught epsilon r. Why I am not writing the mu r here? For all dielectrics, mu are getting as 1, that's why this value is not counted. So Vp is equal to 3 into 10 power 8 by root epsilon r, because since 1 by root of mu naught epsilon naught is nothing but 3 into 10 power 8, right? Okay, so that is the answer there. Vp is equal to, so for dielectrics, definitely we require the dielectric constant of a particular medium. This is all about that the phase velocity. For phase velocity, we consider there is a single frequency propagates, right? Before I want to start at this, the group velocity, let me discuss the dispersive medium. Okay, what is the dispersive medium? Different frequencies travel with different velocities. Okay, on a particular medium, let us consider there are the different frequencies travel with the different velocities, then the signal get distorted at the end of the transmission line, then this phenomena is called as an dispersive medium. The dispersive medium concept is very important. Why the signal get distorted at the end of the transmission line is a beautiful concept to understand the transmission line. Okay, that's why, because of the dispersive medium only, we want to define the group velocities. In the phase velocity, there is only a single frequency, whereas when you consider that group velocity, different frequencies travel with that different velocities. The concept was there. Okay, let us take, I have the two angular frequency, let us take omega 1, omega 2, or that two angular frequencies I have. Okay, then beta 1 and beta 2, they are two phase shift constant. Okay, so I have the two different considerations of omega 1, omega 2 and beta 1, beta 2. What is the group velocity? As the name the group velocity Vg is equal to d omega by d beta. What is the d omega? Differential omega is nothing but omega 2 minus omega 1 by beta 2 minus beta 1. Very popular expression it is for getting that the group velocity Vg is equal to d omega by d beta, or omega 2 minus omega 1 by beta 2 minus beta 1. The definition it is the ratio of change in angular frequency to that the change in the phase constant, right? Exactly, the d omega means the change in that omega values to that change in that the beta values, or nothing but the phase constant, right? Okay, so many times it was given on exams on this, what is the relation between the phase velocity and group velocity, because we have discussed that the phase velocity is nothing but the wave propagates with single frequency, and in the group velocities the wave propagates with that different frequencies, right? Can you find any relation between these two parameters? One is that, let us define the phase velocity Vp is equal to omega by beta, and I want to do the differentiation with respect to omega. Okay, that means d by d omega of Vp is equal to d by d omega of omega by beta. Can do that differentiation. Okay, so this is nothing but dVp by d omega is equal to, it is by u by v formula. U by v formula, it is d beta into d by d of this one nothing but 1 minus omega into d beta by d omega by beta square, nothing but v square. Let us take beta into 1 minus omega into d beta by d omega by beta square. Can you write this one as a beta into beta? So 1 beta get here. Okay, so that beta into d omega by d omega into Vp is equal to beta minus of omega into d beta by d omega minus beta. Again, we take that common as a beta, so one can cancel 1 minus of omega by beta into d beta by d omega. Then, but since we know Vp is equal to omega by beta and Vg is equal to d omega by d beta. Okay, so we know the formulas. Can I substitute? Omega by beta is there, replace with that Vp, and d beta by d omega. Actually, it is d omega by beta, but that's why it is a 1 over of Vg, right? Okay, yeah. Then take that beta into d by d omega of Vb into Vg is equal to, because the term getting here, okay, Vg minus Vp there. Then Vp is equal, I am expecting that Vp answer, Vp is equal to Vg minus beta of this, beta of Vg minus. Let us take this expression for a simplification. D by d omega of Vp into Vg is equal to Vg minus Vp, or Vp is equal to Vg minus of beta into Vg of d by d omega of Vp. Take Vg as common, it is 1 minus beta into d by d omega of Vp there. That is, finally I got Vg is equal to Vp by 1 minus beta into d by d omega of Vp. This is the way how these two factors are related to each other, the group velocity and the phase velocity. Okay, so whenever the Vp tends to 0, okay, whenever the omega value tends to 0, then Vg becomes the Vp. Both values are same, depending on either the beta value is 0 or where omega is tends to 0, then this value. For the waveguides, as you consider the waveguides, Vp, the phase velocity, is equal to lambda naught by lambda g into c. That is the expression where lambda naught is nothing but the cutoff frequencies as you consider. Okay, then Vg is equal to lambda g by lambda naught into c. Multiply these two things. Vp into Vg is equal to lambda naught by lambda g into c multiplied with lambda naught by lambda g into c. They get cancelled. Then finally Vp into Vg is equal to c square, where c is called speed of light in free space, right? Okay, speed of light, that value is 3 into 10 power 8 meter per second, right? I think for this particular topic we are familiarized about what is the phase velocity, and the expression for the phase velocity Vp is equal to omega by beta and Vg is equal to d omega by d beta, and the relation means Vg is equal to Vb by 1 minus beta into d by d omega of Vp, These three are that very popular expressions to you, and so many times on online it was given that what is this value? This value is nothing but Vp into Vg is equal to the c square. Okay,